Okay, welcome to today's lesson. Before we start, I just want to have a little request, and that is to begin today's lesson, you have to finish the previous day's lesson on simplifying radicals. If you have not done it yet, I would say please take a moment to do that first. Then you come back to this video, because if not, that would cause quite a bit of confusion. Okay, because what we do today, it's quite similar to what we did on the previous in the previous lesson. And if you don't understand what's going on in the last lesson, then yeah, it just won't end well at all. So yeah, please, I put the link down below. You can in the description, so you can check out the link right there. Okay, so first, today's topic, we'll talk about complex number today and tomorrow. Complex numbers. Well, how complex is the complex number? Well, it's not that complex. It's quite simple because the look of a complex number, it is simply a plus or minus bi. Okay, so you have a plus bi or a minus bi. So we would just say a plus or minus bi. All right, so either one. The a and b are numbers. And the new item that it's on our menu, it's the I. Now, what makes it very complex? Well, what makes it very complex is that we have two components of this complex number. The first component is this part that's called the real number part, okay? And then the other component, which will be the focus of today's lesson, is the second part, and that is known as the imaginary number. Okay, so you can go onto YouTube, since you are well, you could be watching this video on Schoology, but if you're on YouTube, or you can just Google search the history of complex number, that could get a little bit more interesting. It talks about how there was a mathematician. He found out the some kind of secret called complex number that's used to solve cubic functions, and he did not tell anybody. And then before he died, he told his student, and then his student got into a little argument with another mathematician. And back in the days, they have this kind of duel, like what each person, it's not about guns, but they would two mathematicians, they will give each other 3 questions to solve, and whoever can solve all those will win the competition, something like this. And that's how the words broke out about complex numbers. So it's a pretty interesting story. I'll strongly encourage you to take a look at it. So yeah, complex number is just about it's a different system, and we will not go too deep into the complex number um, thing, but we will see some of those from our quadratic solving next week. Okay, so what we do today is to prep ourselves. Now, if you remember from last lesson, we were doing simplifying radicals, right? We'll still see radicals today, the square roots. And then we said that all we're doing is prepping ourselves to do quadratic formula, which is a way to solve quadratic equations. Um, that's what we will do next week. Okay, so 2 lessons from this lesson, we will have the um, solving quadratic equations with quadratic formula. Okay, so we'll see the application side later on, but today we will handle what is a complex number, what it looks like, and today we'll spend majority of the time on the understanding of the imaginary number. Okay, so what is an imaginary number? Okay, well, an imaginary number, it happens when we have a negative number underneath the square root. Now, if you pay attention in the past, you probably know that we are not supposed to have a negative number underneath the square root. Okay, now we know like square root of 4, it's 2 because we say, oh yeah, square root of 4, it's 2 because 2 times 2, it's 4, right? So by having a square root of 4, we are essentially asking the question, hey, what number multiplies itself would get you 4? And we say, oh yeah, we know it's 2, right? So that's why we know square root of 4 is 2. But then if we say, what is square root of -4? We tend to say, oh, that's a nonsense question. There are no two numbers that would multiply together to get you -4. That's just nonsense. Well, it was nonsense. It was nonsense up until now. Because we are about to find out that there is indeed a number that would multiply itself that would give us -4. Okay, now let's go ahead and talk to our calculator for a little bit. Okay, if you have a calculator, okay, which I have one right here, and I'm going to type in square root of -4. Let's see what the calculator tells us. It would say error, a non-real result. Okay, now be very careful with this, with the interpretation of what's being shown to you. It says non-real. Okay, it's imaginary. So therefore, it just says it's non-real. And if you read carefully, it says to allow complex calculations, change to real or complex mode, setting to rectangular or polar. Okay, so the calculators know how to tell you. If you put this square root of -4 into your calculator on your phone will probably say it's error or something similar to this. Okay, so that's why we can't really use our calculator for help in this case, right? So now, how do we see it? How do we see it now? I know that on your handout it's already printed out, but I want to just verbally explain to you what's happening here. The way we see this is that we have a -4 underneath the square root, and then we are going to look at it this way. Okay, we're going to break down the -4 into 4 times -1. Okay, now they're both underneath the square root. And then we say, oh, what's square root of 4? So, oh, yeah, we know that it's 2. Okay, we know that it's 2. And then what about the square root of -1? Now, that is our I. That is our imaginary number. So first and foremost is the understanding that square root of -1, it's known as I. That it's our imaginary number. Okay, and we'll see a few more examples so that we can familiarize ourselves with the understanding of the appearance of the imaginary number here. So here we have square root of -36. So I'm going to break it down to 36 and -1, both underneath the square root. And we know that square root of 36 is 6, and square root of -1, it's I. So there you go. Square root of -36, it's 6i. Okay, so if you have a perfect square, that's nice. All right, so whenever you see a negative underneath the square root, then you know you're about to see the appearance of I. So you can just kind of take out or separate the square root of -1 away from any other number, so you can see the appearance of I straight away. Okay, same thing right here. Okay, same thing right here. We have square root of 20 times square root of square root of -1. So that is just I right there. And what about square root of 20? Well, square root of 20, well, 20 is 4 times 5, right? So the 4 comes out, so that becomes a 2. Okay, square root of 4, it's 2. And that's the reason why I gave a little advice at the beginning of the lesson. If you did not go through the previous lesson, if you don't understand the previous lesson, then you should go see that first. All right, now, so we have this 2 root 5 times I. So how do we present our final answer? Now, to avoid confusion, this is how we do it. Okay, this is how we do it. We always place everything in front of the square root, and there's a good reason behind it. Okay, the good reason behind it is because, now you may ask, okay, I think it's a good thing to ask, can we go ahead and write it this way? Well, technically, yes. It's not a problem. People could understand what's going on. The only problem is that if somebody, when they write the square root and they write it like this, then it causes one heck of a confusion, because people will ask questions like, is the I underneath the square root or not? And we're like, let me ask the person who wrote it. So to avoid this kind of confusion, we try to not write it this way. So we just put everything in front of the square root, and whatever number that it's shown underneath the square root, it is the number underneath the square root and nothing more to the right of it. Okay, so that's how we do it. And then for square root of negative 48, again, we will break it down, separate the square root of negative 1 from the square root of 48. So that's I. And then for 48, square root of 48, that's 16 times 3. We saw that from last lesson. So we have 4 root 3 right here. So our final answer is 4I root 3. Okay, 4I root 3 right there. So that is the beginning of our understanding of the imaginary number. Okay, so it's very straightforward. Okay, and we can go ahead and try a few of these questions now. All right, so easy stuff. And I'm not gonna go over all of them because they're quite easy. So I'm gonna go over number 1, number 3, and number 12. I mean number 7. Okay. Yeah, just 3 questions. All right, and then you can handle the other ones, and you can check your answers after you try them. Okay, so same thing. All right. Number 1, we have square root of 80 and negative 81. So take out this square root of negative 1 out. That becomes your I. And square root of 81, it's 9. So there you go, 9I. It's your answer. All right, now for number 3, it's a little bit different. You can see there's a negative dangling in front of the square root, and actually it's just there, right? Don't eliminate it. It's still there, but we'll take care of it afterwards. Okay, we'll do the same thing that we have done in the past. We just look at the square root of negative 64 and take out the square root of negative 1 away from the square root of 64. And we say, hey, square root of 64, it's 8. And then square root of negative 1, it's I. So your final answer is simply negative 8I. Now, I know some of you might be very tempted, okay, that you might want to multiply this negative into the square root. Never, ever do that, okay? Never, ever do that. Because the negative just won't go into the square root like this. Okay, so if it's there, just leave it there. Okay, and let's take a look at number 7. Very similar case. Okay, negative, it's there, just leave it there. We will have square root of 12 and square root of negative 1. And then we have 2 root 3 as my simplified radical for square root of 12, and then we have I right there. So our final answer would be negative 2I, and then times square root of 3. Okay, so that's the intro. All right, that's the intro, and it's very straightforward, very similar to what we did in the last lesson. And then now in the next level, we'll find something, we'll see a little interesting pattern. And we will see some kind of crazy exponents. And for many people, they would get scared, like, wow, we have to do this. That's a big exponent. And then once you once you can see the decode the pattern, you're like, oh, actually, that's not that bad. All right. So click the next video.